This assignment is on optimization. Optimization involves maximizing or minimizing some quantity, typically subject to some constraints or requirements. We'll see more about these in the videos associated with this assignment. We'll look at two applications of optimization, one having to do with energy theorems and the other having to do with limit analysis. And again, we'll see what these are in the different videos associated with this assignment. The first problem in the assignment has to do with application of one of the energy theorems called the principle of total potential energy. And you will see that it involves using inequality constraints on displacements. Again, the videos will explain what inequality constraints mean and so on. The second problem is not one of these two applications, but just a small side application demonstrating that principal stresses are in fact the largest magnitude normal components of largest and smallest normal components of traction. So the second problem is not one of these two applications, but just a small side application. Are max and min normal components of traction. Third problem is the second application having to do with limit analysis. This problem is taken from this book, which you may also find as an interesting reference. This problem involves, so there is a frame structure like this with a certain pattern of loading, and the question is how much can we scale this? So for example, let's say we want to multiply all of these loads by a factor 1.1. Or by a factor 1.2, let's say. So what is the largest factor we can multiply this load pattern by before the structure will fail? That kind of analysis is called limit analysis. And how exactly to set this limit analysis up as an optimization problem is covered in one of the videos. It involves, again, modifying our simple FEA code. But then instead of doing solving k times u equals p, which we've done in the past, we'll do the limit analysis.